Our client has gotten quite clever at detecting our data exfiltration. We need to come up with something else. We're going to try steganography. We will hide a message inside of an image. And then we will perform some steg analysis to try to extract that message from the image. Open up Microsoft Paint or any simple Paint app. Select Shapes and pick a shape. I'm just going to pick Rectangle. Now before you draw the rectangle, come over to Colors, select Turquoise for color 1, select color 2, and select turquoise again, so it'll be pure turquoise. Now go ahead and draw the shape. Just click and drag. You've got this outline. Go over to Fill, click Fill, Shape Fill, and go to Solid Color. Click that. Click Select again. So now we have this solid turquoise shape. We're going to add another shape and have it overlap the first one. The color will be very slightly different. Click Shapes, pick a shape. I don't care if you pick something different. I'll just pick Rectangle again. Before you draw the rectangle, come over to Edit Colors, click that. And you'll notice that turquoise has no red in it. And on a scale of 0 to 255, meaning 8-bit color, it has 162 of green and 232 of blue. So mostly blue, but quite a bit of green also. We're going to reduce the green and blue each by 1. What we're doing is we are manipulating the least significant bit. So change this down to 1 and this to 1. We're just changing the color, but quite honestly, we could instead be using these least significant bits to hide data. Add it to the custom colors. Click OK. Now select for color 1 the custom color you just created. And for color 2, again, select the custom color. Now click and draw your shape overlapping the first one. Click Select. If you look very hard, maybe you will, maybe you won't see a very slight color difference. I have to look from different angles. My monitor is fairly good, but I don't have a really high-end monitor that maybe a graphic artist would use. We're going to superimpose yet one more shape, and this time we're going to go the other way in terms of editing the colors. Go to Shapes, pick a shape, go to Edit Colors. We're going to create a custom color. Now, we went down by 1. Let's go up. Take it to 3 for both of these. Add to Custom Colors. Click OK. Now you have a second custom color down here. Make sure you have your shape handy. For color 1, pick the second custom color. For color 2, the second custom color. And overlap your shape on top of the first 2. Click and drag, overlap, let go. Click Select. If you look very hard, you might see the line. This is the really subtle difference that is used in image steganography using least significant bit. Now, LSB, least significant bit, is not the only method, but it's a very common method. You can go ahead and minimize Paint. It's not important anymore. Let's now apply the concept with an image. You'll need to open 3 websites. The first one is a place where we can hide text in an image using least significant bit steganography. Now, I haven't made up my mind if this is Style Sucks or Style Success. Either way, open up a browser to this site right here. Style Success, I guess, .github.io/steganography. Then open another page to rapidtables.com/convert/number/binary to ASCII. This will allow us to examine the binary that is going to be put into the image. Then go to aparasolve.com, and it will do the analysis of the encoded image. Starting with Steganography Online. I've provided 2 images here. You can pick one or you can choose your own. Just make sure it's a PNG and it's not too big, like 2 megabytes or less. In the Steganography Online page under Encode Message, select Choose File. And select whatever image you want to use. Then type a message. Meet at the donut shop at midnight. Now I have to warn you, if your image is too small it will only be able to hide a certain amount of text, not that much. I've kept my message fairly short. My image size is, about 1.5 megabytes. It should be okay. Scroll down a bit. We can see our original image. Scroll back up. Here's the text. Click Encode. Click. This is the binary that's going to be hidden inside the image. I'm just going to expand this a little bit. We're going to take all of this binary, just highlight it and copy it, and go over to the binary to text translator, click that, and paste it in. Paste. So we're going to translate from binary to text. In the character encoding, this is pure ASCII. Click ASCII. Select ASCII and click Convert. And you can see that this binary has been changed into ASCII, and there's the message. So now we see the data that's going to actually go into the image and what it can be converted back to. Terrific. Go to Steganography Online again, scroll down a bit. So there's the original. Scroll down more. This is the image that has been normalized. It's prepared. And go down to finally see the message hidden in the image. And when I scroll down here, I don't see any difference. They say under Message Hidden in Image, right-click, Save As, Save Image As. I'm going to put it right here with the other images, and I'm going to call it Encoded. Encoded. Save. Here it is right here. Now let's go to a Parasolve, and let's have a Parasolve do some analysis. Take your encoded image and drag and drop it right here. Drag and drop it and click Submit. What this site will do is it will take apart the image layer by layer to see if there's anything hidden there that we can visually see, and it will also look for strings, in other words, text. Scroll down a bit. Now we can see the different layers here. With the binary that we put in here, we're not really going to see the message. However, if somebody had used Photoshop to manipulate some of the layers, that's where it would show up. So we can see just looking at the red, just looking at the green, just looking at the blue, and I don't see any text here, which I wouldn't expect to. On the other hand, if I scroll down a bit, we can see that one of the analysis tools, something called ZSteg, by using red, green, blue, least significant bit, LSB, in an XY axis, it did uncover and decode the text. This other stuff here is probably just metadata from my phone when I took the image, just metadata accompanying the image. Let's scroll down and see if any of the other tools, no, so far nothing from some of the other tools. This one has a little bit of information about the image, and a little bit more, some details about the image. And I don't really see, there are the strings. Here are all of the strings. Like I said, some of this stuff is probably metadata put on there by my phone. But the part we care about has been decoded right here using red, green, blue, least significant bit. So it looks like Steganography will serve our purpose nicely.